Howdy y'all, and welcome to the first episode of the Master Material series. Hopefully in this series, by the end, we will have covered how materials work, how textures work, and have a fully functioning master material ready for your project. Without further ado, let's just jump right in. The first thing that I want to actually discuss is the textures, because that's going to pretty much dictate how your materials are going to work, and we'll get into that in a little bit. But first of all, I've set up an example here of a texture which is utilizing 4 different channels. So you have a red, green, and blue channel, sometimes an alpha, sometimes without an alpha, depending if that particular texture is using it and what it's using for. But the main channels we have here are going to be RGB. Let me move this over a little bit so you can see what I'm talking about in Photoshop. So your texture maps are made up of all 3 of these channels, the RGB, which will come together to form a representation of the color that you see on screen. So how I've packed this map is I've taken, if you're using Photoshop, you can use GIMP, any other software. I'll show you also how to pack maps in Substance Painter if you're using that. But for Photoshop terms, all I've done is I've made sure that I've created a RGB texture under my image mode and RGB color. That will then give me access to the RGB channels here that we see on the right. I've then just soloed the channel and put in a value. At this point, it is just the typing tool for RGBA. And then I did that for each of these channels. I also clicked the add to get an alpha channel, and I put the A in for the alpha. What this texture will do is it will allow us to debug different channels as we go through. You can set it up yourself. It's not too terribly difficult, or you can just use a pre-packed texture that you have available. Next, let's jump into Substance Painter real quick so I can show you how to pre-pack your textures. For this one, I'm going to be following Unreal's basic setup. When I say basic setup, I'm just talking about ambient occlusion, roughness, metallic, and emissions. So once I'm in here, we can go to our export textures. Under export textures, we have output templates, and you can create a new template by just hitting the plus icon. Once you've created a new template, we can rename it. I'm just going to double click on this here, and we'll rename this to ARMH, which stands for my ambient occlusion, roughness, metallic, actually EM. You can put height information or emissions. I'm going to choose to just put emissions into this one. The next thing that we can do is we then need to add a RGB and A texture here. Make sure it's got the plus signs between it, so we can assign different channels. And so in here we can take our ambient occlusion map, we can add it to our A as a gray channel. We can take our roughness to the G, add as gray channel. We can then take our metallic here, also add as a gray channel. And then for alpha, we can take our emissions, take emissive, and add as a gray channel as well. Then we have this texture all packed and ready to go. We can then use it as a preset when we go to export our textures from Substance Painter. With all that out of the way, we will come back into Unreal and we'll go through and show you how to start setting up our master material. So there's a caveat to be had when creating master materials. Either way is fine. It all depends on personal preference, but you can create one large master material. Just know that it does increase shader compilation times. However, Epic's been pretty good at reducing compilation times in UE5, so it hasn't become that big of an issue sitting around waiting for shaders to compile every time you make a change to your master material. Or you can also opt to make just smaller bits of materials that are specialized to what it's supposed to be doing for that asset. Please keep in mind that if you have specialized materials, you do need to assign material IDs to your object for each material, or at least make instances which you can assign. If all that's above your head, don't worry, we'll get into it as we go. Right now I just have this basic asset of the hatchet that I've made, and I have the textures for the hatchet. And what we're going to do, as you see here, we can take a look at the textures. So as I bring up the albedo map, there we go. So as we look at the albedo map, you can then see what I was talking about here. We have the R, G, and B channels. Each one of these channels has a black to white value. Depending on the black to white tells this channel how much blue information is being passed through. Same thing with our green, how much green information is being passed through. And of course with the R, the same thing. Those three channels actually come together, and depending on the value that we're receiving from these channels, it makes up the colors that we see on our screen, from browns to grays and so forth. So with that in mind, the first thing that we're going to do, let me delete this, so we don't need it, and we'll start from a very clean slate. So first thing I do is in my content folder, I've made a material library folder. I've assigned a color to it so I can better pick it out visually. And in here, we're going to go ahead and create a new material. I right click and do create material. I'm going to name this M underscore master, because this will be my master material. So the way I'm going to go about showing you how to do this is we're going to set up things modularly. So if you prefer to do customized smaller materials for your assets, this will still work. I'm going to go with the first option, which is creating a large master material and incorporating all the functions into it. You'll see what I mean as we do this, so don't worry. The reason we're going to start with functions is that functions are basically small snippets of code that we can repurpose in different materials to access the same logic. So we create a material function folder. We're going to right click, go up to material, and create a material function. I'm going to name this MF underscore albedo. And this is going to be representative of all of my color information, albedo or color, base color maps. We can then open this function, and we're presented with the material output. So this is going to be a result of whatever code and logic we put inside of this function. So if you are familiar with blueprints, it's the exact same concept of using a function inside of a blueprint, just specifically for our material case. So first thing I'm going to do is we need to have a map. So I'm going to make a material input, or a function input, sorry. We're going to change this to the type of texture 2D. And I'll explain why we're doing it this way here in a little bit. But once we have our texture 2D input, we can then assign a preview by just looking for a texture object. And we just hooked it up to our input there, and then this will output a result for us to see. First, what we're going to need to do actually is read from this texture object to get our texture channels. So off of the texture 2D, we can then assign a sampler, a texture sampler. You can just hold down T and click into your graph and assign that to our texture input. From here, you can see that it breaks down the RGB channels and A channel, the alpha, for us. We can output the RGB, or we can also output all of them together, RGBA, or we can just grab from a single channel. We plug our RGB in right now, we can see that we get the preview. And between here is where we're going to want to start to add in all of the logic to manipulate our base color or albedo map. So first thing we'll probably want to do is we'll want to adjust the overall intensity of our albedo map. And how we're going to do that is I'll hold down M on my keyboard and click in my graph to get a multiply. We'll plug this in to our multiply node. And another thing that I need is a way to control this intensity. So I'm going to right click and do another function input. We're going to make this actually a scalar input. And then I'm going to hold down 1 and click in my graph to get a constant. We can plug that into our preview so we can preview this. I'm going to put a 1 as the constant. And then we can hook that up to our B of the multiply. And you'll see how all this comes together as we go through. So now I've got the ability to basically change my intensity. If I put a 0.5 here, you can see it knocks the intensity down. 0.2. We go with something like 5. It's really blown out. That's how we're going to control our intensity. So next, what I'm going to want to do is control the tint. So again, we're going to hold down M for a multiply node and click in our graph while holding M. And instead of using just a single vector constant, I'm going to hold down 3 and click in the graph to get a 3 vector constant. And we're going to need an input for this as well, so I'll do another function input. And this time we actually want it to be a vector 3, which it is by default, so we'll keep that. I'll plug this top in, which is the RGB output, or the 3 vector output, into my preview, and then I can plug this into my multiply. File that. And then we can also plug this into our result to preview the result. We'll see now that we get black because we've actually tinted our albedo black by this 3 vector constant. I like to set this as white as default because it's just basic and neutral. But we can come back and we can now control the tint of this material. If I go to blue, it tints it blue, red, so on. But for this purpose, I'm going to keep it white for now as the preview. Next thing that we'll probably want to do is also control the overall saturation of the material. This is purely optional. It's more an artistic direction. Sometimes I find that materials or the colors can be oversaturated and they need to be toned down a little bit for more real-life values. So in order to accomplish this, what we're going to do is we're going to right-click and type in desat, and we're going to get desaturation under color. We can then add that to our node structure. And we're going to need another scalar input. So I'm going to copy this one, make sure that it's set up here, and then we can actually copy Control-C, Control-V, our constant, and that's going to go into the fraction. Now, as you notice, we have just black and white values right now for our color. All the color information is gone, and that's because what desaturation does is it takes a 0 to 1 value, 1 being that it desaturates the color 100%. 0 means no desaturation, so I'm going to change this to a 0, and we'll get our color values back. But between 1 and 0, we'll actually be able to maintain and create how saturated our colors are. So with all that in mind, the next thing that we're going to need to do is to organize our function. So first thing that I'm probably going to want to view on my function is actually the UVs. So I'm going to actually do another function input. I'm going to make this a 2-vector, since UV's texture space operate only in 2 vectors, the X and the Y. So from here we can then add a constant. And what we're going to need to do to preview this, if we just plug a constant in here and put it in the UVs, we're going to notice that our texture is gone and we can't see anything. And the reason being is that we've fed in just a hard constant value into the UV space, and there's no actual information for this to read from as far as the UV space. So we need to add that back in. So how we'll do that is we're going to look up for coordinates. So texture coordinate. This is going to give us back our UV coordinates in UV space, and then we can multiply this constant by our texture coordinates and plug that into our preview. It's still going to show that there's nothing there, and that's because we haven't given anything a value yet. So if I put a 1 in here, then bam, we'll get our texture back. This essentially is how we're going to end up using this setup to tile our textures. There's a lot to do with the coordinates, and there's a lot of different effects that you can do by manipulating UVs, and we will definitely get into that a little bit later as we build out our UV function. For now, this is just a preview though, so this is looking good. What we're going to do, however, is, like I said, we're going to organize these inputs the way they're going to be displayed on our function node once we pull it into our master material graph. So I'm going to put in some reroute nodes, keep this a little bit clean. I suggest always trying to keep your node structures clean so that you can come back and read from them and figure out what's going on later, so it's not a headache. You can also select all of these and do a Shift A to left adjust align everything. And then comes to the housekeeping on the actual inputs themselves. So for this, I'm going to say this is UVs. I'm going to set the priority as 0. And what the priority does is the lower the value of the priority, the higher it's going to sit on the node structure. And as you increase the value, the lower it's going to sit. So I'm going to say a 0 for this. Next one I want in line is my texture. So I'm going to put this as 1. And I'm going to rename this to albedo map. Next one is going to be my intensity. So I'm going to say intensity. And this is going to sit as number 2. Our tint. Call this tint. Number 3. And finally, our desaturation. Desaturation, and else is number 4. Awesome. And this will output our result. So for now, we can go ahead and save this material function. All right. With all of that done, the next thing that we're going to want to do is create a new material function in our material functions folder. So I'm going to go to material function, and this mf underscore material or base material. And we'll open this up. And inside of this function, I'm actually going to drag in our newly created material function albedo. This is going to require some inputs, so we're going to come back over to our material function albedo, and I'm going to copy all of these inputs plus the previews. Control C, pop back over to base material and Control V, and plug these into the function. Very good. And I'm going to rename this output result to albedo. We can then save this function and open up our master material. Inside of our master material, we can then drag in our newly created material function base material. And then start assigning it some of these properties. So for now, with the UVs, we're just going to get a texture coordinate and a constant. Again, I just hold down 1 and click in the graph to grab a constant. We can multiply the two. And plug that into our UVs. Next thing we're going to need is a texture object parameter. So I'm going to right click in my graph and do texture object parameter at the very bottom here. And we're going to name this albedo map and plug that into our texture 2D input on our material function here. Next thing I'm going to want is intensity slider, so you can actually just hold down S and click in the graph to get a scalar parameter. We'll name this intensity. Give this a default of 1 and plug that into our intensity there. Then we need a vector 3 for color, so hold down 3 and click in your graph to get a vector 3. You can right click and convert this to a parameter, and we're going to name this tint. We're going to change its default value over here from black to white. And then we're going to take the top pin, which is the RGB values combined, and plug that into tint. And the reason we're using the top pin and not the bottom pin is that the bottom pin includes the alpha. Is that when you try to plug in the bottom pin, sometimes they'll give you an error, basically just saying that you are trying to feed more channel information or more vector information into something that only accepts 3 channels. It's quite common on trying to put a 3-channel vector into a 2, for instance, and it'll give you an error message. And then finally, we'll need our desaturation. So I'm going to copy my intensity, Control-C, Control-V, rename this to desaturation. I'm going to give it a base value of 0. And one thing that we're going to do with this particular scalar parameter is we can set the min-max values. That way we don't accidentally give it some wacky value and we don't know what's going on in our instance. So this way it just hard sets the value, so the slider will only go between there, because we know it goes from 0 to 1, and plug that in. We can then put this result into our base color, and we should be able to see our result there. Going to save this. The other thing I'm going to do real quick is we're going to assign a group to these parameters so that they're easily a lot more easily readable within our material instance. So first thing we do is we grab our albedo map, and under a group here, we're just going to say, I'm going to call this 1 and albedo settings. And then I'll assign these also to the same group. And from here, what we can do is assign the priority. And again, this is a 0 is the top priority in your instance. So I'm going to set our map here as the first one to be displayed in order. Our intensity as 1 under the priority. Tint is 2. desaturation is 3. And we can save that. And with all that done, the next thing that we're going to end up tackling here is going to be the normal map. So for the normal map, we'll hop back over to UE5. What I'm going to do is create a new material function. We'll be doing this a lot. mf underscore normal. And I'm also going to create one more material function. Material function. And I'm going to call this one mf underscore normal scale. Let's go ahead and tackle the normal scale first. So the normal scale function open, what we want to do is basically take the R and G channels of the normal and set the intensity of those. We can also control whether they're inversed or not. So we're going to make a function input here. We're going to keep it as a 3 vector because this is going to be our normal. I'll hold down 3 and click in here and just give the B channel a value of 1, which represents my normal. Then I'm also going to put in a couple more function inputs. This one is going to be a scalar, so let me grab function input. Over here on the type, we'll change that back to a scalar. And I'm going to copy and paste this. And we'll give this just a constant value, 1, and this one a constant value of 0. Then we're going to rename these inputs. So this input is going to be our normal. This next input is going to be the intensity. And our final input we're going to call flatten. If I can spell that right, flatten. Okay, and then we're going to do a bit of an operation to manipulate these channels. So what we'll do is grab the output of this function, and we're going to do a break out float 3 components. From here, we're going to get ourselves a couple of multiplies. For our intensity, we're going to plug this into the B. We're going to plug our R from the breakout components to the A of the top multiply, and the G to the bottom A of the bottom multiply. After that, we're going to recombine these vectors, so I'm going to drag off of this and say append many. So we have our R and R, G and G, and then we can connect our blue back to blue here. Of course, we can kind of clean this up a little bit with some reroute nodes. Probably better down here anyways. All right. And the final thing we're going to do is a flatten. So I'm going to do a lerp by holding down L and clicking into our graph. Our RGB is going to be in the A. And then I'm going to copy this constant here and reuse it for the B value. And then this flatten input will be our alpha. And then from there, we'll plug our result in. And we're going to save this. So with that done, we're going to now bounce over to, actually, before I get ahead of myself, let's make sure that these are in the proper order. So my normal in is going to be 0 priority. My intensity I'm going to make 1, and the flatten I'm going to make 2. Sorry about that. Prevent having to come back and do it later. So let's go ahead and save that. Now we can close it, and we can open up our normal. So here in the normal, we're going to do essentially the same thing that we did with the albedo. So we can copy this because we're going to need these guys. So I'm copying the texture coordinates, the object, and the intensity inputs. We don't need the multiply because we're going to be using our newly created function. I'll go ahead and paste in here. I'm going to rename this texture 2D input to our normal map. Keep UVs the same and intensity the same. And then I'm going to copy this and paste, and we're going to set this value to 0 on the copied constant, and we're going to change this copied input to flatten. On the texture object, I'm going to actually grab a default normal. Under the search here. Just going to grab a default normal texture. And then we're going to bring in our normal scale that we created. And we can drag in the RGB to the normal. We can drag in our intensity into the intensity, and then we can drag our flatten into the flatten. We'll then hook up our result to our output. And we can save that. And this will be our base normal. So we're going to come back into our material function base material. We're going to drag in our material function normal. And we're going to do the same thing. We need to recopy those inputs. So if I go to my material function normal graph, grab all of these material function inputs and previews, go back to our material function base material and paste those. We can then plug those into this material function normal. And then we're going to need a new output. So I'm going to copy my albedo output and rename this to normal. And our result we can plug in there. Then we can go ahead and save this material function base material and pop back over to our master material. And one thing I noticed, I want to be able to categorize these better, because since we copied them, they're just putting these inputs in various positions. So we're going to fix that. Go back over to your base material function. And we're going to continue off on the priority sorting here. So the desaturation was set to 4. This UV input, actually, now I'm thinking about it, we're going to utilize something a bit different to clean this up. So I'm going to delete this input. Yes, it's fine. We're then going to grab this input And then we're going to drag off of this input and type in named. And you're going to see where it says add named reroute declaration node. Here we're going to then put in UVs. And with our brand new declaration node created, we can then come over to our functions and just under named reroutes, select UVs and plug that in. Then we can copy that and paste this below to use as a UV for our normal too. Because essentially these are going to keep the same UVs anyways, so that they both scale appropriately. With that taken care of, we'll pick up where we left off on the priority sorting. So we had, again, desaturation was 4. So I'm going to make my normal map 5. The intensity for that 6. And the flatten 7. And since we've got 2 intensity inputs, I'm going to rename intensity 1 to normal intensity. We can go ahead and save this function now. Come back to our master material. And we should see that all of these pins have then aligned themselves to the bottom of the function. So I'm going to copy both the albedo map and the intensity inputs or parameters. I'm going to paste those here. Rename albedo map to normal map and intensity to normal intensity. And then I'm going to go ahead and copy our normal intensity, paste that, and name this one normal flatten. Then in our normal map, we need to change the default texture to the default normal. And we're going to go ahead and plug that into our normal map 2D, the intensity into the normal intensity, and the flatten into the flatten. All right, so with all of that done, that should be the basics of the normal setup. So the final thing that we're going to want to tackle is going to be our PBR setup, which is our physically based rendering. We're going to follow the same workflow, although this is going to be a little bit different. So in here, what we're going to do is we can actually just copy. We're going to duplicate our material function albedo. And instead, I'm going to name this to MFARMEM, which is abbreviation for ambient occlusion, roughness, metallic, and emissions. Let's go ahead and open up that duplicated function. So some things in here are going to remain the same, and some things we're actually going to change. First thing, texture coordinates are fine. The next thing that we want to change is this map. So we're going to change this to ARMEM map. We no longer need the intensity, the desaturation, or the tint. So we're going to go ahead and delete those. We will need 2 scalars. Yes, we'll delete that function. So I'll keep these 2 scalars. And I'll show you what we're going to do. So previously I mentioned that we could use the packed data for different values other than color. Well, in this case, what we're doing is we're using the value from the R channel to drive the intensity of the ambient occlusion, the G channel to define what is smooth and rough, and the B channel to define what is metallic. And our A channel is going to be our emissions mask, which we can output and use later when we create our emissions function. So I'm going to drag off of our red here. Actually, I'm going to hold L and do a lerp. And what we want to do is we're going to use this red channel as our, which is our ambient occlusion information, as the alpha. Then with these two scalar inputs, I'm going to rename one to AO min and the other one to AO max. I'm going to give the max a default of 1 and the min a default of 0. Your minimum should go into the A and your maximum into the B. We're going to need to replicate this process 2 more times at least for your roughness and for your metallic. So I'm going to copy this setup and we're going to paste it again. We'll put our G into the alpha of the second lerp. And then I'm going to rename this to roughness min and roughness max. Just going to copy that and paste, change them into max. If you're confused about the difference between roughness and smoothness, they're the same thing. It just depends on the engine in which is using them. So smoothness is just a roughness map, but inverted. It's usually used by Unity, whereas UE4 and UE5 uses roughness. That's the only difference. Go ahead and copy these and paste these for our metallic and plug our blue channel into the alpha of our third map and rename these inputs to metallic min and metallic max. And from here, we have a few choices that we can do. We could output each individual channel. However, I think what I'm going to do is actually combine these. So I'm going to append many. And I can break these channels later on in the material graph if I need to access each individual one later. And then I'm going to output the RGBA as our output result. Few changes we're going to need to make to the structure here. First one being the color. We're actually going to use default mask. Default mask. Let's see, that's not mask. Here. Default mask texture. The reason we're using a mask is that I've set up my ARMEM texture as masks under the compression settings. Why do that? Because we're not actually using it for color. We're using this as an alpha mask to drive the white and black values from our lerp. This also saves on overhead. Make sure our function is saved, and then we can come back to our base material and go to our functions and grab our newly created material function ARMEM, and we're going to do the same thing. Our output, and our output is going to be ARMEM. So we're going to go on ahead and copy all of these inputs from our material function ARMEM, and then come back into our base material function, and we can paste those. We're essentially grabbing everything except for the UVs because we've already got a setup to handle those. And we're going to go ahead and plug these in. Let's go ahead and actually order these guys. So if I go back into my ARMEM function, set priorities. So this will be 1, UVs is 0, and then we're going to go with AO min is 2, AO max is 3, roughness min is 4, roughness max is 5, metallic min 6, and metallic max at 7. And now we'll save that and come back to our base material function, and this should be reordered. So now we can go ahead and we can plug in all of these inputs. And of course, copy our UV named reroute node and plug that into our UVs. We can then save our base material function and head back over to, actually, before we go to that, we also got to make sure we've set priorities on these guys too. So off of the flatten, we had 7. So let's go ahead and put our map for ARMEM is 8. 9 is the AO min, 10, 11, all the way down, 12, 13, and 14 for metallic max. Okay, so now we can save this. The other thing that I probably want to do is organize the outputs. It's purely up to you, but I usually like to keep them in order. So on my base material here, I'm going to have albedo as 0. I'm going to put my normal as 1 and ARMEM as 3, just to reprioritize those outputs. Go back into our master. And then we need some parameters for our ARMEM. So I'm going to go ahead and copy my normal map here and paste that. We're going to change this to ARMEM. And I'm going to get the masked default mask texture. Plug that in. And then I need a few scalar parameters for our min max inputs. So I'm going to copy the normal intensity and normal flatten. Control C, Control V, and we're going to set these up. So I'll name this one AO min and this one AO max. And I'm also going to set up some default min and min max values. On our min, we want the default to be 0 and the slider max to be 1. And on our max, let's just do the 0. There we go. On our max, we want the default value 1 and the max to be 1. I'm going to copy this and rename this to roughness. One more copy to metallic. Plug in all of these. And then we're going to set the groups here. So instead of albedo settings, I'm going to call this 2 normal settings. And I'm going to put my intensity and flatten into normal settings. And for my ARMEM, I'm going to put 3 and call this PBR settings. And also put these in the same group, PBR settings. Then we just need to prioritize them. So normal map 0, intensity 1, flatten 2, ARMEM map is 0, AO min 1, AO max 2, roughness min 3, roughness max 4, metallic min 5, metallic max 6. You may be wondering why I've decided to make a material function for just a material instead of putting it directly into the master material itself. The reason being for that is that later we're going to blend separate materials with separate features, and this prevents us from having to do all these hookups all over again. And we can just take the result of our material function based material nodes and blend those instead. And why we left all of these parameters in the actual master material itself and not inside the function is for the same reason. When we have duplicates of this function, if we have them all named the same, then whenever we tweak this actual parameter, it'll tweak the same thing on both, and we don't want that to happen. We want them to have separate values. The other thing that we can do is we can drag off of this and do a named reroute. We can call this, let's say, base albedo to try and set us up in the future when we have a secondary material. I'll drag off of this one, same thing with a named reroute, and call it base normal. And I'll drag off of the ARMEM, named reroute. Also base PBR. Then for our output, we can go ahead and grab our named reroutes and plug them in just to keep our graph cleaner. And off of our base PBR, we can then, for now, break out float, 3 components. R is going to be our ambient occlusion, G is going to be the roughness, and then B is going to be our metallic. All right, so quite a bit to set up. The next part we're going to tackle, and hopefully the final part, just to set up the very base of our master material, is going to be the specularity, the height, and the thickness, which we will then use to drive subsurface properties. So let's pop back into UE5. Luckily for this, we've already got kind of a base set up with our ARMEM function, so I'm just going to duplicate this and rename this to CTSH. This stands for cavity thickness, specularity, and height. Cavity is kind of specialized, you don't really need it, but I figured since I'm already packing the maps, I might as well use the channels, and we can use that cavity information to drive other features. Going to open up that newly created function, and we're going to make a few minor changes. Number one being the naming. So I'm going to rename the map to CTSH. We're going to keep it as a mask texture, and then rename our AO to cavity. Roughness to thickness. And our metallic to specular. Then we can save that. Come back over to our base material. We're going to need to grab all of those inputs again, so I'm going to highlight actually all of these inputs except for the UVs. I'm going to copy that, and in our base material function, paste them. And we can continue to organize these. All of these will pick up where we left off on our metallic max. So CTSH map I'm going to put as 15 and continue numbering these all the way down the chain. So ending with our specular at 21 as the input. Let's go ahead and drag in our newly created CTSH material function and put in our hookups. So I'm going to copy our UV rerouted name declaration node for our UVs. CTSH map is our texture 2D, and then plug in all of these inputs here. Then we can copy this output and we will output CTSH as a result. We can save this now, and with that out of the way, we can then jump back into our master material. We can then copy all of these ARM-EM inputs or parameters and paste them and rename these as well. This will be CTSH cavity instead of AO. Thickness instead of roughness. And our metallic is going to be our specular. And we'll go ahead and hook those up. And we now have a CTSH output. Let me fix the priority on this. I'm going to put this as last. So I'm going to set priority to 4 on the output in my base material function. Save that. Now it's at the bottom. Again, we can drag out and do named. And CTSH. Then go to our named reroutes, grab that. Temporarily, we're also going to do a breakout float. And really all we need at this moment in time is just our specularity. So I'm going to grab the B channel off of that and plug it into specular. Save this. And we also need to make sure that these are properly aligned in our PBR settings. So we'll continue off of metallic max where I had it set priority of 6. CTSH map will do 7 and continue naming or numbering them down the line. 13. Great. There's one more optimization that I want to make, and this has to do with the texture samplers themselves. Textures have a maximum of 16 samplers. However, there is a way around that. If we go to our material functions, let's start with our CTSH, and we come to our sampler, you're going to see over here the sampler source. If this is just left as texture asset, it's going to create, or it's going to use up a sample slot. But if we instead come to this and do a shared wrap, it will actually just sample from the shared wrap component. We can also alternatively do a shared clamp. The difference between these two is that wrap will allow you to actually tile the texture, as where a clamp is just clamped to the 0 to 1 in UV space. So let's go ahead and go back into our material functions and do that for all of our samplers. We'll go into our albedo, grab our sampler. Let's go to shared wrap. ARM-EM, same thing. To our sample and sampler source to shared wrap. And finally our normal. Change our sampler source to shared wrap. Great. And with all of those base functions set, what we can now do is for our asset, we can right click and go to a material and go material instance. And I'm just going to name this mi underscore hatchet because I have a hatchet here that I'm going to use it for. I'm going to then double click on my instance and we can assign a parent. And the parent that we want to use is, of course, our m underscore master. As soon as we assign the master, we'll see that all of our settings that we've now put in show up. We have our albedo settings as number 1, normal settings as number 2, and our PBR settings as number 3, and of course they're all aligned appropriately. And what we can do now is we can tick on these properties next to our texture 2Ds to assign some maps. So I'm going to plug in my albedo, my normal, ARMEM, and our CTSH. And with that material instance done, I can then come to my asset, open up the hatchet, and we can assign it up here. I'm just going to click assign because I have my material instance highlighted. And there we go. So this first episode was a long one, I know, but we had to get all the base stuff out of the way first. In future episodes, we'll start focusing on modular setups, mainly to do with the albedo and a little bit more manipulation of the PBR settings and normals. So until then, have an awesome day and happy deving. We'll see you next time.